Good morning, everybody. How are you all? Today we are going to talk about area of a surface of revolution. So without further ado, let me share my computer screen with you. Says set up and evaluate the definite integral for the area of the surface generated by revolving the curve about the x-axis. The curve function is y equal to x squared divided by 6 plus 1 over 2. Let me make sure I've copied it correctly. Plus 1 over 2x. And the limits of x are between 1 and 2, both inclusive. Okay. So to solve this problem, we will use the formula for surface of revolution. So we have, if y is equal to f of x, have a continuous continuous derivative on the interval AB. Okay. Then the area of the surface of revolution formed by revolving the graph of f about the horizontal axis. Let me write it. Of f about the horizontal axis. The horizontal axis is S is equal to 2 pi integration from A to B, limits of integration, Rx times square root of 1 plus f prime x square x. This is under squared dx, where Rx is the distance. So we have to clarify that, where Rx is the distance between the graph of f and the axis of revolution Okay, so we are going to use that formula. So let me move this a little bit up and create some space. Okay. So we write given, okay, that's fine. Given given y is equal to x squared by 6 plus 1 over 2x. So let's find the first derivative of y with respect to x. Okay, so y prime, sorry, this was x cubed, so let me correct that. X cubed by 6. So y prime is equal to 3x squared over 6 minus 1 over 2 is constant. So minus what might I do? Half x squared. X to the power of minus 2, because x minus 1 derivative is x minus 2, so which derivative is minus 2, so the power comes to the denominator. So now we will find 1 plus y prime square, and that is equal to 1 plus 1 plus 3, so it will become x square by 2 minus half x square square. Okay, and if we expand it, that will be equal to 1 plus x square x4 to the power of 4 plus 1/4 x to the power of 4 minus 2 times x square by 2 times half x square. Okay, so that will be equal to, so again we are, let's create some space here and move it up. So now 1 plus y prime square is equal to, I'm opening up the parenthesis, is 1 plus x4 over 4 plus 1 over 4 x to the power of 4 minus, what is minus 2 goes with 2, this 2 will cancel with this 2, this x square will be gone, and I'm left with minus half, right? Yeah. So this will be equal to x4 over 4 plus 1 over 4 x to the power of 4 minus, plus half, which can be further simplified into x square by 2 square plus 1 over 2x square square, okay, plus 2 times x square over 2 times half x square, okay. So this is nothing but x square by 2 plus 1 over 2 x square. The whole thing is squared, okay, because this is of the form a plus b square, where a is equal to x square by 2 and b is equal to 1 over 2x square, okay. And this is true in the interval. So this is true in the interval 1 to 2. And that's a closed interval, so it is written like this. Okay. So now if we use the formula for S, so let me create some space here. And I will change the color of the pen also. Let's go to this color. Yeah. So S is now equal to, so I'm using the formula for S. So S is equal to 2 pi integration from 1 to 2, okay, x cubed over 6, that's the original function, plus 1 over 2x, okay, times, okay, and you have square root. So square root makes this x square. So you put plugging in the term for, so square root of 1 plus y prime square is equal to x square over 2 by 2 plus 1 over 2 x square. And that's what you are going to plug in here. X square over 2 plus 1 over 2x square, and that's dx. So if we keep 2 pi, so s is equal to 2 pi, integration limits from 1 to 2, okay, you have x cubed by 6, you're distributing x cubed by 6 to, you're using the FOIL method, first term. Then the outside term is x cubed by 6 times 1 over 2x square, okay. Then the inside term is 1 over 2x times x square by 2, okay. So, and the last term is 1 over 2x times 1 over 2x square and dx, okay. So let's simplify this. So the s is equal to 2 pi limits of integration from 1 to 2. So you have x to the power of 5 by 12, the first term. X to the power of 5 by 12, okay, plus you have x over 12 okay, plus x over 12, okay. And then you have plus this one is x over 4. And the last term is 1/4 x cubed. 1/4 x cubed and dx. Okay. Now if I create some space here. So s is equal to 2 pi. Limits of integration are from 1 to 2. And this will be inside the parenthesis here, x5 over 12 plus x over 3 plus 1 over 4x cubed and dx. Okay, so this will be s is equal to, so s is equal to 2 pi. I will now do the complete the integration. So it will be x6 over 72, okay, plus x square over 6, okay, and I have x cubed, so minus 3 plus 1 is, so it will be minus y minus, because your power of x is, exponent of x is minus 3, so minus 3 plus 1 is minus 2, and that minus 2 is going to the denominator, so it will be minus 1 over 8, and the power of x will be minus 3 plus 1, which is minus 2, which means it will be x squared in the denominator. And the limits of interim are from 1 to 2. Okay. So now it's a question of plugging in the limits correctly. So 2 pi, you can write 2 over 72, 2 to the power of 6 over 72 minus 1 to the power of 6 over 72. Let's keep it all inside, okay. Plus 2 square over 6 minus 1 over 6, and then minus 1 over 8, and that will be inside the parenthesis 1 over 2 square minus 1 over 1 square. Okay, so let me create some space for myself. Okay, so my s is equal to s is equal to 2 pi, then 2 to the power of 6 over 72. Now 2 to the power of 6 is 64. 64 over 72. So 2 to the power of 6 is 64. Let's check it out. 2 cubed is 8. So 8 times 8 is 64 over 72. So 64 over 72 minus 1 over 72 plus 2 square is 4 over 6 minus 1 over 6. This is a 4. 4 over 6 minus 1 over 6 minus 1/8. You have 1, 2 square is 1/4 minus 1. Okay. So again, simplifying, this will be s is equal to 2 pi. Inside the parenthesis, the first term is 63 over 72 plus you have 4/6 minus 1/6 is, let me erase this minus sign sticking out. This is not how. So I'll erase that. So this is just 1/6. So 4 minus 1 is 3/6. And then you have minus 1/8 times minus 3/4. Okay, which can be simplified to S is equal to 2 pi 63 over 72 plus 3 over 6 minus, and two minuses make it positive, 3 over 8 times 4 is 32. Okay. Okay. Now we have to find the common denominator between 72, 6, and 32. And that will be, what will that be? That will be, if we work out the common denominator or lowest common multiple of 72, 6, and 32. We will first divide this by 2, 36, 16, and 3. And then we will divide by 4. So 4 times 9 is 36. This will still be 3. And 4 times 4 is 16. Is there anything common between them? Yes, we can take 3 as the common factor. So 3 times 3 is 9, 1, and 4 left over. So the LCM is 2 times 4 times 3 times 3 times 4. What is that? Is 8 times 9 times 4, or 72 times 4, which is 288. So let me create some space for myself. So this S will now become 2 pi. I'm reducing everything to a common denominator of 288. So 72 times 4, and this one will be 63 times 4. Plus 6 goes into 288, 46. 6 times 46 plus 3 times 46. 48 rather. 48. Yeah. Plus 32 goes into 288 9 times. Okay. So 3 times 9 divided by 32 times 9. In that case, S is equal to 2 pi. 63 times 4 is 4 3s are 12. 24 252 divided by 288. 3 times 48 is 3 8s are 24. 12 and 144 divided by 288 plus 3 times 9 is 27. 32 times 9 is 288. Okay, which if I create some more space, so S is equal to 2 pi, and you got to add all of this. So 7 plus 4 is 11 plus 12 is 13. 4 plus 2 is 6 plus 7. 6 plus 1 is 7 plus 5 is 12. And 423 over 288. Let me make sure. 6 and 7 is 13. 6 and 7 and 5 is 12. 3 and 1 is 4. Okay, so this is the final answer. So S is, and you can of course simplify, is 2 pi multiplied by 423 by 288. Okay, now let's simplify, which is S. We take out the common factor of 2 out from here, so pi times 423 divided by 288 divided by 2 is 144. Okay. Now we can take a common factor of 3 from the numerator and denominator. So it is pi times 141 divided by 3 fours are 12 and 24 is 48, right? Yes. And again, further, we can take another common factor of 3 out. And so this is pi, 3 fours are 12, 47 divided by 60. So the final answer is S. So after all the simplification, we get S is equal to 47 pi over 16. That's your final answer of the surface area generated by revolving the given function around the x-axis. So I hope you are able to follow me. If you have any question, you can write me a note. If you want to make a comment, please go ahead, make a comment. If you like this video, please give me a thumbs up and please share this video with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will be back next time with another important problem, interesting solution. You know me, I get back every day with new problem, new solutions. And so do not miss any of my videos, okay? Thanks for watching and leave me a comment. I'll appreciate that. Thanks for watching. Take care. Have a nice day. See you next time. Take care.